CFD analysis on Y-shape fitting. In this video, you will learn about how to model this Y-shape and how to run the analysis on CFD. To do this, open Inventor. Ensure your units are millimeters, drawing standards ISO. Next, open Assembly. Click on New Assembly. Click on Create. Specify the part name. You can specify Y-shape pipe. Press OK. Click anywhere on the screen. It will take you to the modeling environment. In the modeling environment, click on Start 2D Sketch. Select a plane of your choice. Specify the dimensions. For example, I need 500 line and then 280 lines. I'm assuming the angle between this Y shape is 60 degrees. So, based on this information, I will start the sketching. So, this dimension, the horizontal dimension, is given to me as 500 millimeters. Then it is specified that the length of the pipe, one end of the pipe, is 280, and the angle between the pipes, I'm assuming it is 60 degrees. So it will be 150 degree angle here. So I will specify that 150 degree angle. As you can see, the angle, you can press tab on your keyboard to select that angle, and then you can enter the value as 150. Okay, you can double check it from here as well. 150 and 280 is the length. The next step is to select the line again and specify the other opening of the pipe. In this case, as you can see, the angle is coming from the horizontal axis. And as I said earlier, the angle between the two pipes should be 60. So if there is 30 is this angle, okay, then I can have 30 more to have that 60 degrees overall angle. Press tab to select that angle, and initially enter the length, which is 280 millimeters. Then press tab to enter the angle and enter as 1, which is 30 degrees. Press enter and it will make the two sides for you. You can double check this by clicking on dimensions, select this and line, and select this line and double check the dimension. So the angle is 60 and everything else 500 millimeters, 280 length. They are according to our requirements. Once you have done this, finish the sketch. Click on Return to go to the assembly environment again. At this point, click on Design, Insert Frame. Save the assembly file first. You can name it anything, for example, Y shape fitting. You can save it in the location of your choice. Once it is saved, specify the frame you're going to put. Have a look at the dimensions. It says greater than or equal to 100, greater than or equal to 80. So select the category round tubes. Ensure you are in ISO. You can use the standards which are specified to you. Choose the family of the beams, and from here you can specify the sizes. So I'm going ahead with 101.6 times 6. I will explain the reason. Once we specify this size, select the lines to make these frames, press OK, and press OK. 101.6 times 6.3 is my size I have selected for the frame here. Now I can go to Inspect and double check the dimensions, measure. So in this case, outer dimension was specified to me was around greater than 100. So I can check the outer dimensions from here, which is 101.600 millimeters. So that's somewhat closer to my requirement. I can also check the inner dimension by clicking on it, and it is around 89 millimeters, which is greater than or equal to 80. So approximately closer to this. So I will accept this. So that is why we went ahead with 101.6 times 6 size of the frame. Once you have confirmed both dimensions that they are according to your requirements, you can close this window, go to design and go to assembly. Stay in the design. In the design, yes, you can see uh, they are overlapping each other. The frames are overlapping each other. You can double click on any frame and you can see that they are overlapping on each other. To resolve this issue, you can use the design commands given to you. You can notch, you can use miter, lengthen, shorten, trim, extend, whichever seems sufficient to you, or you can model it in any other way as well, whichever seems sufficient to you. I'm going to use miter. I'm going to select all these three beams. I'm going to press OK, and it will automatically join these beams together for me. I can double click on any beam to see whether it has been according to my requirements. So this is according to my requirements. Okay, I have got a split end here. I've got the split end here as well at the same point. So assuming my requirement has been met, and this is the Y-shaped fitting I needed for this type of beam. So I'll press return, save this file. Ensure now you export it as SAT file. Just click on file, click on export, CAD format, save it to the location you need. Ensure from save as type you select SAT files and then click save. Just to let you know, you can open this model directly into CFD by clicking on simulation and then active model if you have the same versions of CFD and Inventor. If you don't have the same version, let's say if you have 2019 CFD and you have modeled this in 2021 Inventor, then it won't open into the CFD analysis. So if you have the same versions 2021, you can just click on active model. It will directly open into the CFD. Start the CFD app, click on new, click on browse, and ensure you find where you have saved your SAT file for the Y shape fitting. So open the SAT file, not the assembly file. Click on design study name, specify a name, let's say Y shape fitting. Great. It says edge merging tool may prove useful for this model. So what it will do, it will reduce the complexity of this model by merging a few edges. For example, it will merge the edges here as well, and it will merge the edges here. What will happen with this, the meshes, it will be easier to do the meshes, and it will be easier to refine the surface and to view the flow of fluid through these edges as well. You can click on merge and merge the edges. And that's it. Close the geometry tools. The second thing you should do is to save this model somewhere which you can access again and again. Let's, for example, you can save it in the downloads. Specify the study name, for example, Y shape fitting study. Click on save, and it will save the model for you. Once you have done this, click on output bar to minimize and enhance your modeling environment. Right click on geometry, change the length units to millimeters. Specify the geometry tools. Click on void fill. You want to fill the void inside this Y shape fitting. So you need to close all the openings. So click on the edge, click build surface. Do the same on all the openings. Build surface. And lastly, just click on fill void. It will automatically fill the void from here. At this point, you can double check your model for any existing errors. You can check whether the void is according to your requirements. So press escape, press Ctrl on your keyboard, and you can minimize all the shapes like that. So this is the void which has been created by CFD analysis tool. To bring your model back, you can scroll up to bring your model back, or just click the middle mouse button by pressing Ctrl. Once you have got the void, the next thing you should do is to specify the materials. To specify the materials, you can specify the materials from this side as well. Okay, so this is the CFD created volume, which is the one inside these brackets. So what you can do, click on edit, specify the material as fluid or water. Then you can select the remaining bodies, which is this one, and that one. Click edit, specify the material type as solid, specify the name for the material, steel, press apply, and this will make this model according to your requirements. Specify the boundary conditions. If I'm assuming this is my inlet and these two will be my outlets. So at inlet I have got velocity magnitude in meters per second, and let's say I'm going to use the figure according, I'm assuming this will be 150, but you're going to use according to your requirements. So let's apply. This will specify the velocity at the inlet and specify the pressure at the outlet. Select the outlets and specify the pressure as 0 and apply. So this will specify that these two pressure 0, and this will be the outlet. This is where the water will be flowing. It will be going from inside here and it will be dividing into Y shape at the front and going out from the outlet. Once you have specified this, click on mesh sizing, specify the mesh size. You can use auto sizings for the mesh sizing. And once you have specified the mesh, click on solve and run the simulation. Keep an eye on the convergence plot. If the values are varying quite a lot, then you may need to run more iterations. You can visualize the results while the results are running. Click on this just plane and then you can view the results from here. So this is the distribution of velocity through the pipe. You can right click on it, plane result. This is the velocity magnitude. You can also look at the pressure magnitude where the maximum pressure will be, and right click, plane result, and you can view the velocity as well where the velocity will be higher. You can refine the mesh further. I can see from here in my model that the mesh is not much refined and there is quite a lot of variation in the results I'm getting across this, and the number of elements are quite low as well, 19,000. So I will refine the mesh further, and I can see from the convergence plot as well that the values after 75th iteration were coming similar. So the number of iteration I can keep as 100, but I need to refine the mesh further to get more accurate results. To do this, we'll click on mesh size, and I can click on edit, specify the type as manual, and select the entities you want to specify the mesh for. Ensure you select the inner void as well, which you created using CFD from the front here, and by default the mesh size is 23.93. I can refine it further. You can refine it with increments of 1 and plot a convergence plot like this to show the mesh convergence studies. You can decrease the mesh size by 1 and until you get the similar results and show the convergence plot. Otherwise, you can just define the mesh directly from here as well. You can, let's say, I will define the mesh to 10 size, press apply, and then click on solve simulation. Start from 0th iteration. This is a much more refined mesh as compared to what we had before. You can visualize the results when the simulation has started. We'll wait for the results to complete and we will be back once they are completed. You can visualize the velocity distribution and it is quite smoother at 10 results as compared to what you had before. You can visualize the turbulence flow here as well. Now that the results are completed, as you can see, the results are quite different as compared to what we had before, and the flow visualization of the flow is quite smoother and somewhat realistic as compared to, again, what we have had before. You can visualize the flow via the traces as well. You can click on plane, you can remove the plane from here, make sure you are in left, and click on traces, specify the type of traces you want to have. You can have diamonds, hexagon, grid. Specify the seed density. Initially it was specified as 1. Let's say I'm going ahead with 1.5 density. I can click on add, and then I can add the seeds from here. It will show the flow of water to that farm. Again, this is just a very simple basic CFD analysis to view the flow of water through the Y-shaped pipe fitting. But again, I have taught you about the mesh settings, how to refine the mesh in the manual mesh setting, but we haven't gone into the wall layer settings where we can specify the refinement next to the walls of these objects, and we haven't talked about layer factor or layer gradation. This is what we will talk in the upcoming videos, but for the time being, this was how to run the basic analysis using Autodesk CFD. And for the time being, we are also looking at the internal flow of the objects. We can also look at the external flow of the objects, internal flow of air or aerodynamics of the objects by playing around with the geometric tools, and we can create an external volume which could be working as a wind tunnel. So for the time being, again, this is how you will run the simulation. This will show you the velocity magnitude. You can right click anywhere on the screen and you will be able to view the global results in terms of pressure as well, which will be 9.4 times 10 raised to power 6 pascals maximum. You can visualize the pressure where it is going to be as well. You can turn off traces and you can create a, for example, plane and add the plane, and then just click on the plane, specify the axis, and then you will be able to view where the maximum pressure of the motor is going to be. That's all. That's how you will run the simulation. You can change the result mode as well by clicking right click on the plane result, and you can see view the velocity magnitude as well and the pressure alongside it. That's all. Thank you for listening.